We are now live. We can start.
You're live. Okay. Good afternoon, ladies and gentlemen. It's my pleasure and privilege to welcome all the participants to the distinguished lecture series on energy efficiency. This is the sixth in series which we have been holding on the first Monday of every month for the last 6 months. We are privileged to have Mr. Tejpreet Chopra, founder and CEO, BLPindustry.ai, to be here with us today and deliver the distinguished lecture on energy efficiency. Mr. Tejpreet Chopra, popularly known as TP, and is a GE veteran. Has got a distinguished career in General Electric, and he was the president and CEO of GE India, Sri Lanka, and Bangladesh. He has 22 years of global experience, both in terms of management and finance. Apart from his distinguished career in General Electric, TP has been contributing a lot to various boards of companies in India. He's on the board of SRF Limited, Anand Group, and for many of us in this group, he's also on the board of India Energy Exchange. This also might interest you. He's also on the board of the Power Sector Skill Council, a member of the National Council of CII, and also co-chair of World Economic Forum's Global Future Council on Advanced Energy Technologies. Apart from all this, Mr. Chopra also happens to be a national swimmer and a very avid sportsman with interests in golf and racing. Apart from all this, the distinguished career which Mr. Chopra had, Mr. Chopra has one very unique quality. He makes all the listeners who listen to him, whether there's a one-to-one conversation or a large conference, extremely comfortable and comes down to the level of the listener to deliver whatever he has. We are very privileged to have Mr. Tejpreet Chopra to be here with us and deliver the distinguished lecture on energy efficiency. Over to you, sir. Thank you.
Thanks very much, Kiri. Thank you very much. And thanks, Kiran, for giving me the honor and the privilege of inviting me to speak at this event. I'm actually deeply honored given the fact that it's you and Kiran and the whole team at the Green Business Center that's been doing fabulous work over the many years. And also really privileged because of the fact that prior to me, there were such amazing people like Dr. Mathur, Mr. Unikrishnan, Mr. Purushottam, Mr. Suresh, and Mr. Ranganathan who've actually come and spoken. So really appreciate this kind invitation. And I'd love to share with you my perspectives about energy efficiency and sustainability, something that's very close to my heart over many years. If it's okay, I'm just going to put on a few slides to start with. You see my slide, Kiran, can you see my slides?
Yeah, it's just coming up, sir. Just one. Yeah, now it's up, sir. We are ready.
Perfect. So let me just kick it off, first of all, by just focusing a little bit about the macro. And I think some of these points were actually covered prior to, by the speakers prior to me. I think there's no doubt there's been a significant shift ever since COVID has started in terms of the focus on energy efficiency and sustainability. I have never seen this movement start the way I've seen it over the last 6 months. And specifically in the building sector and the factory sector, I think when such a disruptive moment in the history of economics and business has happened, everybody's focusing on the very minute details of every cost item when they're doing any manufacturing process. And therefore, this whole focus on energy efficiency is now becoming very critical. If you think about it, in India, the building sector itself takes up close to about 30% of all the electricity consumption is taken up by the electricity sector. And I've seen certain statistics that somewhere between 700, 900 million square feet is going to be built every year. But when you take a step back and you see the kind of improvements that have happened over the last 10 years have been quite phenomenal, whether it is in passive design elements of buildings, of materials, composites, active systems of pumps, VFD, whether it's in terms of glazing, lighting, high efficient chillers, envelope designs, radiant cooling. So there's been a lot of work that has actually happened over the last 10, 15 years in the whole sphere of energy efficiency. So then I take a step back and I said, okay, what's next? What do we do next? If all these efficiency progress has happened over the last 10, 15 years, what's next? And that's really the purpose of my coming here today, to share with you what we are thinking about the what next is in terms of AI and IoT, and how we believe that's going to be the next frontier in driving energy efficiency and sustainability. And I'll give you a perspective, not only from an energy efficiency perspective, but I think sustainability is taking a more macro view in terms of security, safety as well, to give customers that experience of when they go into buildings. So let me just quickly give you a quick background about what Industry.ai is. Industry.ai is a completely independent technology group within the BLP group, focused purely on enterprise AI and IoT technologies. Now, let me just quickly share as to why we set this up. Our core business is to build, own, and operate wind and solar farms. What I was noticing was that when you operate large investments in wind farms, it's usually of the smallest component that actually shuts down a $3 to $4 million turbine. And that kept happening until one day, 5, 6 years ago, my turbine burned down to ashes. That's how the OEMs, GE, Vestas, Siemens, Gamesa, Suzlon, and change the game. We can't carry on like this, where every time a turbine fails, then we go about there trying to fix it. So we created this industrial digital platform. It's called Orion, where we started collecting hundreds of tags of data onto the platform. And using AI, we were able to predict failures in a gearbox, generator, bearing, blade, hundreds of hours before the turbine shut down. And as a result of that, we improved machine availability from the high 80s to the high 90s. And we saw a huge result in returns on investment. So that's how this journey started. And now we focus on three things. How do we improve productivity and reliability in manufacturing? Obviously, different industries, different things. If it's oil and gas, it's machine availability. If it's the auto sector, it's OEE. Two is how do we reduce cost and energy efficiency? And the third one is quality and sustainability. So those are the three parameters we focus on. Now, we started out by doing it on the renewable side for our own assets. And then slowly, a lot of the large global utilities around the world came to us and said, listen, can you help us out also improve machine availability on all our turbines as well? So as a result of that, today we collect data from thousands of wind turbines and solar farms all over the world, France, Germany, Spain, Italy, Portugal. We get the data onto our platform. And from our control center in Bangalore, we can predict failures in these machines all over the world. So that's how this journey started. And over time now, we have people who actually climb up on ports, who climb up 120 meters, up those big key cranes you see on a port. We put our sensors and our gateways into the trolley and the hoist. We get the data out to predict failures in the key crane before the ship comes to the port. And we ensure the throughput of the container through the port is actually maintained. We do quite a bit of AI work for the world's largest refinery in the cracker plant, in the paraxylene plant. We digitize production flows. And we do a lot of AI work for one of the world's largest FMCG companies to actually use the power of AI to drive productivity in manufacturing. But I was just joking with a friend of mine that I said that coming from a world where we made aircraft engines and turbines and healthcare equipment, I've now got a deep found respect for people who make soaps and shampoos, because in that particular case, a 2% variability in the moisture content, when you're making over 1.5 billion soaps, can actually result in significant amount of losses and wastage. So that's the power of AI and the ability to actually track machines and improve productivity, whether it's in steel making, auto making, or in the real estate space. So we focus on just 5 key things. The first one is asset health and machine performance. So you can connect any data, any machine, anywhere in the world, and predict when it's going to fail. We do that not only for wind turbines and solar farms all over the world, but also for transformers in Europe, where we can get the data and predict failures in the transformer before it actually shuts down. We actually do a lot of supply chain optimization. So trucks and trains are easy because you have a power source. Where railway wagons were more difficult because there's no power source, so we had to put our sensors and gateways under the wagon to track how it moves and predict when it's going to fail. We'll talk a lot about today about smart buildings and healthy buildings and energy efficiency today, on how we're changing the game on that perspective. We do a lot of work on ports, like I mentioned to you, in order to improve productivity, and a lot of work on asset tracking and inventory management, because today we have the ability to put a screwdriver on a 30-acre factory and find it within 30 centimeters. And we do that by putting a little tag the size of a button on a shirt, with which we're able to find real time where the assets are at any manufacturing process. So with this, we're able to track man, material, machine flows on any production line to drive sustainability in the manufacturing process. And I'll share with you a little bit more about how we actually do that. And lastly, we do a lot of work on visual analytics to convert any camera anywhere. No new capex, no investment. How do you make any camera anywhere in the world think like the human brains? And I'll share with you how we are applying these technologies in the world of energy efficiency and sustainability. So basically, the core team consists of 6 core groups. The first one is enterprise AI. So we have a large team of industrial this, just focusing on taking vast amounts of data and making sense out of it. 2 is IoT. What we find is that in a lot of factories, people don't know how to put which sensor, which gateway, and how to get the data out. So these are the guys who climb up 120 meters up on key cranes, on trains, on wind turbines, on factory floors, where we actually go out there and put the sensors and the gateways in order to get the data out. We manage a lot of data. Track and trace, it doesn't matter, truck, ship, or train, anywhere in the world, we'll track where it is and predict when it's going to fail. Visual analytics, like I said, by giving the camera like the human brain, we can see good guy, bad guy, if from a safety, security perspective. And lastly, we're doing an R&D project with one of the world's largest turbine makers and with GE right now to really change the way we do AI. And that's going to have a huge implication, especially in energy efficiency. Because in normal SCADA PLCs, we might get 100, 200 tags a minute. On electrical signals, we can get 5,000 tags a minute. And that quantum of data gives us the ability to predict failures, whether it's LV motor, MV motor, generator, inverter, has gone up 10x in order to be able to drive efficiencies using AI. So what we really do is 3 things, and these are the 3 fundamental bases on which energy efficiency is going to change going forward. And I think this is the future in terms of what we're going to see. The first one is connectivity. How do you make hardware talk to software? How do you in buildings or in factories to talk and get the data out? And normally that's quite difficult. And the reason that's difficult is there's no standardized protocol. So how do you make hardware talk to software? Once you get the data out, what do you do with that data? In other words, how do you take all this vast amounts of data to drive energy efficiency, whether it's a building or a factory, or whether it's any other parameter that goes into driving sustainability? And the third one is automation. In other words, it's not about humans doing it. It's about giving machines and the computers the power to think like the human brain to make all this happen. So this is in one page what we do. We install the IoT devices, we don't make it. We get them from all the big companies, the world, Emerson, Honeywell, GE, Siemens, Cisco, ABB, etc. We install these IoT devices into the building of the factory. Now, in some cases, the system might already be installed. So we just connect it to that. But we also work with a lot of small, very specialized sensor companies in Finland, Sweden, Israel, Germany, California. We install these IoT devices. We have our own edge protocol, which basically communicates with all these protocols of all these multiple sensors that exist in the world. Now, the reason why people underestimate how difficult it is to cleanse the data, because there's so much structured and unstructured data that comes out, that cleansing data takes time. We are currently connecting close to about 220 solar farms all across Europe from one of the biggest utilities. And I get a lot of grief from the CEO saying, if you're not moving fast enough to cleanse the data. And my point to them is it's not that easy, because think about it. Every inverter manufacturer's got his own protocol. Every country's got a language protocol. There are different data formats. Every country's tracking different KPIs. So to get all that data and cleanse all the data so that the scientists can actually start looking at it takes time. So we cleanse the data on the edge. Then we push the data onto our industrial digital platform. It's called Orion. That's where all the algorithms sit. And then you create the application, whether it's for driving energy efficiency for a building or driving energy efficiency for a cement factory, a steel factory, or aluminum factory, regardless of what factory that is or what industry it is. You design, customize the application based on what you want to drive. So that's what we do in one page, all the way from installing the IoT device, we just extract the data, do all the AI work, and then to drive changes in driving energy efficiency across different factories. Now, all these AI algorithms, we've developed close to about 100 proprietary algorithms over the last 6-7 years, creating one of the largest industrial digital databases. Now, in order to develop one algorithm, it can take us 8 months to a year. So it takes a lot to develop one algorithm to drive it. And these algorithms, when you look at it, can fall into 6 broad categories. The first one is failure prediction. How do we actually predict a failure in a machine 100 of hours before it actually shuts down? Whether it's a wind turbine, whether it is an HVAC on the building, whether it is a furnace, how do you predict a failure before it actually happens? So the key word is, how do we go from a reactive approach to a proactive approach? How do we predict failures? 2, how do we actually do anomaly detection? In other words, how do we go down to component level, whether it's a wind turbine or a solar farm? Can we go down to the gearbox, generator, bearing, and predict a failure at the component level before it actually shuts down? We obviously provide recommendations. Then you have the dynamic threshold, because what we are noticing is any machine in different parts of the world performs very differently, regardless of if it's exactly the same machine, same make, same model. And this could happen for a variety of reasons. It could be weather, it could be, it could be part of a different production line. So we're seeing all these differences, and therefore, for example, in wind turbines, a wind turbine operating, the same wind turbine operating off the western coast of Ireland performs very differently than the same wind turbine in Gujarat and the same wind turbine in Sweden, because the characteristics are different. Therefore, we create dynamic threshold algorithms that adjust its way up or down based on these environmental conditions. So an HVAC system in Chennai might be very different from an HVAC system in Bangalore versus Bombay. The energy consumption patterns would be different, vibration thresholds could be different, and therefore you create these dynamic thresholds. And finally, we create a lot of asset health predictions to figure out, why is it that 20 machines out of 80 turbines are creating more energy than the other 60? And that's what we keep on doing constantly. And therefore, if you look at it, this is just a few of the examples of some of the machine learning algorithms and computer vision algorithms that we have developed over the last many years. But when you think about it, one of the biggest challenges, Kiran, is how do you actually drive a return on investment in Industry 4.0? And that's becoming one of the biggest challenges when I talk to CEOs around the world. They all want to do it, but the question is, what do you do? Is there going to be a return? And what are the benefits you're going to get? So what we try to do is look at it over the last 6-7 years, look at all the algorithms we've done across a variety of industries. And therefore, if you can see on the x-axis are all the industries, y-axis is some of the algorithms. That over time, what we found is some algorithms have a higher correlation of success in certain industries. So whether it's the building space or the auto space or aluminum or steel or sugar, what we're able to do is figure out over time and our experience which algorithm aligns best with which industry, and therefore it shrinks the time in order to see success and get better returns on investment for companies that actually invest in all these processes. And therefore, that's what we've been trying to do, regardless of whether it's an energy project or a waste management project or an OEE project. How do we actually drive faster results in across a variety of industries? And therefore, what we do is install a variety of these little gateways, sensors, meters, and therefore there's such a large variety of it. The question is to figure out over time which is the right sensor and the gateway to get the data out reliably. What we found over time is that react very differently in different machines, whether it's a chiller, whether it's a boiler, whether it's a furnace, because vibration is different, loads are different, stresses are different, temperatures different. And therefore, over time, we've made our own mistakes. We failed a couple of times with a couple of sensor makers. We failed a couple of times with a couple of gateways. But I think over time, one gets a good sense as to which sensor works best with which industry and what application in order to drive these efficiencies. So now coming to what I call connected buildings and connected factories. If you take a step back, I really believe that a couple of the reasons that's driving this whole movement of being able to create the concept of a connected building are a couple of factors. One, sensor costs have come down dramatically over the last 6-7 years. Now, when you're putting a sensor that costs, say, 80,000 rupees or 70,000 rupees in a crane that costs $15 million, that as an absolute number, 70,000 rupees is still expensive. But yet, if you look at it, what it was 5 years ago to what it is today, it's shrunk dramatically. All the way through to very cheap sensors, whether it's an occupancy detection detector in a building or a large, very sophisticated sensor that goes onto a 50 million crane, sensor prices have come down. Mobility. Today, we have the ability to get data from any corner of the world, whether it's a turbine sitting in Germany or France or Sweden or Bangalore. We can get all this data reliably. Three, we have the cloud, which is the same for everybody, which is making scalability much, much more easier. Fourth is we have the ability to do high performance compute. And the fifth thing, that India have an opportunity to become global leaders in the world of AI and IoTs because we have the human capital that understands technology to scale for the world. And that's what I want to stress that we can do. Now, coming specifically to buildings, the reason why I believe there's one of the biggest challenges in buildings and factories is the following, right? What I've noticed in the building space is sort of similar to the challenge I saw in the wind turbine space, is that there is no standards in the building space. Why do I say that? All the large manufacturers, whether it's Siemens, Honeywell, Emerson, Johnson Controls, all the big companies that make some of the best technology that go into all these buildings, there are no standard protocols. And therefore, it's very, very difficult to get that data out. Two, the system is broken because there's no alignment between all the stakeholders that actually run buildings. Now, in factories, it's different. Factories, you have from management, CEO to the factory worker, we're all aligned in one perspective, which is, improve output, improve revenue, reduce costs. Whereas in buildings, it's different. The building owner, the cost of energy, etc., all flows through to the tenant through his common area maintenance charges or CAM. The facility manager doesn't pay for it because he just gets a fixed sum regardless of how much energy is saved. And the third challenge is the tenant. The poor guy, comes to work every day and he just gets the bill at the end of the month and he has to cut the check. So the whole business model is a little broken. And that's what we wanted to sort of solve, is that how do you really fix this problem? And when you go to that 330-300 rule, which is, if you look at it, $300 is what the cost of people are. That's your most expensive asset. $30 is the cost of your rent and $3 is the energy cost. And therefore, people don't really focus on that. People would rather focus on the people, the tenants, and your rent, not on the energy cost. So therefore, the question is, how do we take a more holistic approach of looking at a building like a city and look at all the parameters to bring in to drive energy efficiency and sustainability? So the first one is standardization, which is that connectivity layer that I talked to you a few minutes ago. How do you make that standardized? How do you extract data regardless of whose hardware it is, whose IoT it is, we get the data out. Two is, when I go around India, my team and I have walked up so many buildings on the building rooftops or gone and seen a lot of chillers, HVACs, and whatever that exists behind that you don't actually normally see. And it amazes me how little sophistication there is in the world of connectivity in terms of technology in buildings. There are very, very few buildings who actually have sophisticated BMS systems and energy management systems in buildings. So far, I've been to so many, and I've only seen literally a small percentage of people. And that's what gives me the hope that we can drive and change energy efficiency in our country by digitizing the whole process in order to make it work. And as a result of that, why I get more excited is the fact that you're going to drive customer experience as well, especially in the time of COVID going forward. So therefore, what are we trying to do and how do we actually do that? The first point is a single unified platform, because what we see today is that you have a system for your water, a different system for air, gas, electricity, steam, fire, security, safety, energy, light. Each one has its own little system and its own little component. So the question is, can you use the power of AI and IoT to bring all of it together onto one platform? And what do we want to do? One, absolutely drive down efficiencies, improve efficiencies to reduce costs, whether it's energy, maintenance, security. Look at it as a holistic package to bring it down. Two, in the world of COVID, everybody's frugal. So how do we go to a place where we actually convert CapEx to OpEx? Three, how do we drive carbon footprint down? And lastly, how do we increase customer experience? Whether that is through air quality, whether that is through the whole experience of creating a safer and secure environment. And the real objective is not only to do it, to help asset owners to drive carbon footprint, but how do we give tenants and people the confidence to actually come back to the workplace and start working again? So what we did was take all the suite of technologies, not only about energy efficiency, but look at sustainability from a more holistic perspective. to drive not only energy efficiency, but safety, security, COVID, and extract all this data in real time, which really transforms the way one actually does energy efficiency and sustainability to create what I call the healthy buildings or the healthy factory. And that's what we're trying to do, is to take a more holistic approach to bring all of it together. So when we look at buildings, right? So what we are actually trying to do is we put our sensors into not only the HVAC and the chillers, which is the most obvious one, but how do we look at it also from transformers? How do we look at the DG set? How do we connect the lighting, the air quality, water, waste, ETP, STP? So look at sustainability from a more holistic approach, connect every parameter of a building and get the data out. Now, in most cases, we see that the BMSO is only connected to the energy system parameters. So in those buildings, what we do is go out there, put the sensors and the gateways to actually get the data out. On the industrial side, what we're actually seeing is 5 areas on the industrial side, whether it's a steel factory or any manufacturing company. The real drivers of energy efficiency in all these buildings are sort of 5 big buckets in our view. And it's just a start, because a lot of this has not been done before. We're all doing this for the first time. The one is process and process control, whether it's process heating, cooling, water. How do you actually drive efficiencies in process control? In terms of furnaces, what we're looking a lot to do is in terms of reducing scrap, because that creates a lot of excess energy. And I think that's one of the single largest factors, especially in steel plants. And the question for us is, how do we use AI to improve the yield in the furnaces, especially boiler and steam distribution? We really believe that steam generation can actually, we could potentially save 10 to 30% of energy costs in steam generation. Process utilities, whether it's compressed air, an idling compressor can actually consume close to about 40% of the load that actually happens. So the question is whether you look at, large factories or whether you look at steel factories, the ability to digitize critical areas of the steel factory or any factory to get all the data out, that's when we're really able to drive efficiencies. Now, what we also see in a lot of factories are motors and fans, and that actually consumes a lot of energy as well. And therefore, that's where a lot of the failures happen. So if we can look at it not only from an energy efficiency perspective, but from a maintenance perspective, that can actually go a long way. But what we've seen is just a 20% VFD reduction in motor speed can actually reduce power consumption by close to 50%. But the question is, all these factors, you really don't know unless you have the ability to get that data out in real time, do all the analytics to drive these efficiencies going forward. And therefore, what do we really do from a product perspective? One, we've got to make it from a modular perspective, because no company or no building has all place up front. And therefore, we got to take it as a modular approach. First, take the energy part of it. Then later on, we attach fire. Then we attach security. Then we attach wastewater. So you take a modular approach. 2, the interoperability with any hardware that exists. It doesn't matter what system they've put in the past. It doesn't matter. The third one is open architecture, because what I find generally is that most of the OEMs have hard-coded devices that extract the data only to themselves. So the question is, how do you create an open platform where it doesn't matter what systems you've installed, will get the data out? And therefore, what are the real benefits? The real benefits, you want to improve the customer experience. You want to drive operational metrics. And if you don't have the data, there's no way you can drive that operational metrics. How do we improve security and safety for people coming to building environments? How do we improve the financial metrics? But the future is really this. The operational stuff is the here and now. Where I see the next generation taking it from an energy efficiency perspective is reducing CapEx. When we see the investment that goes into buildings, the kind of backup to backup being created, N+1, N+2, whether it's a chiller, whether it's a HVAC, purely to save itself at one time when everything actually goes down. So therefore, if there is a way to create more efficiencies in CapEx going forward, that will really change the way buildings are constructed or factories are constructed going forward. So let me just dive more specifically into the energy efficiency part of things to just give you one little example of how we actually use these AI to really drive these efficiencies going forward. When you look at it, a lot of buildings have these BMS systems, but I think, like I said, the biggest challenge is the fact that while we can look at occupancy detection, lighting, power management, energy efficiency, not all the buildings actually have everything, connected at one shot. And that's one of the fundamental challenges that we see, in all these buildings going forward. And the question is, how do we create the next generation of an intelligent system to combine the data with the AI to make those intelligent decisions? And therefore look at it not only from a BMS system, but water, air, gas, electricity, steam, to look at it from a more holistic approach to get all that data out to drive these efficiencies. So what are the key aspects? It's first one is temperature compliance. Whether it's a building, how do we actually set temperatures remotely to make it a more better customer experience and drive energy efficiencies? From our control center, control all the movement of these things automatically rather than have manual intervention for people to go up and change set points, for example. Preventive maintenance. Why is it some HVAC chillers fail more often? Can we predict these failures? Drive energy savings. I think remote reboot is a little more controversial at this stage because at least on the building and the energy efficiency side, people generally are not comfortable giving us control like we might do on the wind turbine side. But I think the day will come where people get more confident that give the power to computers to make those decisions. And finally, in terms of remote diagnostics and to avoid power misuse. So we do three things. We get data. We use the AI and the algorithms to drive savings, and then actually make insights or provide insights to the customer, who the facility manager or the asset owner, to actually see it. But what you're doing is giving the power of data to the asset owners of a building or a factory. So today on your iPad, you can actually now track, if you have 20 buildings across the country, how each building is performing from a cost perspective, maintenance perspective, and drive all these efficiencies as you go across your entire fleet across the whole country or even across the world. So what we do is eventually create this application. And this application on one, whether you do it on a web application or the mobile phone, gives you one consolidated view to be able to track all the parameters that go into driving a building or a factory, or actually tracking all its operations to drive those three things: operational metrics, financial metrics, and the customer experience. How do we actually drive it through technology? And then some of the CEOs want all this information on the power of their hand also, and therefore create a web application or a mobile phone application where you can track. The CEOs of one of the largest utilities in the world is tracking his 2,000 wind turbines on his phone to be able to see at a high level which turbine is failing, which is not failing, and what's going to fail when. But what amazes me in India is even the basics don't exist. The number of buildings I go to where even the basic billing system and the energy billing system, where you have 350 meters that are not digitized or not connected to the billing system or the BMS, doesn't exist. So what I find is one has to actually go down to the basics in some cases, where the first step is to at least digitize the billing system and then go on to drive energy efficiencies. But what we've seen is just by giving people the power of data, drives people to make different decision making as they go along to make energy savings happen going forward. I'll just quickly walk you through just one case study, and just to give you a feel of how do we use this data and how do we use this AI to drive efficiencies in these buildings. Now, this particular case study was actually for one of the largest software tech parks. They had multi-tenanted building, many people out there, and what they were trying to do was figure out a way to drive energy savings. Now, what I'll just show you is a very small area of the project that we did for them, where what we wanted to do was really drive energy savings and use forecasting to optimize the energy consumption, whether they should buy the power from the energy exchange, whether they should do it from solar, whether they should do it from DG set, whether they should take it from the grid. So they want to know what we want to do. So what did we do? The first time was we actually connected up the BMS system, additional sensors and meters onto the factory or into that park where we wanted to get all the data out. Then we developed the AI algorithms to actually predict the set point of the chiller based on the ambient conditions. So we actually have developed forecasting models for weather, correlate all these weather forecasting models for day ahead, month ahead, to be able to take all that to coordinate what the set points are going to be and then drive it. As a result of it, just for a very short period of time, just by changing the set points based on these algorithms, we were able to achieve, based on the seasonal impact, anything between 1.5% to 5%, and actually save them over 8% of energy costs in just 6 months. So this is just a quick example of some of the output. And I joke with people because when I show output like this is actually months and months of work of developing that one algorithm that actually takes all this data, chiller data, occupancy data, weather data, all of that together to actually come up with actually setting what it is. So you can see out there in red what the ambient temperature is. In the blue, you can see what the predicted set point should be. So that's what the algorithm actually gives out to the building owner. But you see in the green is the actual set points. And as a result, what you're seeing is that even though the algorithm, you don't really require the set points to be so high or so low, creates the energy inefficiencies in that particular buildings to drive energy savings in this particular tech park. A second one was to do with chiller health diagnostics. What you can see out there in the chart on top is that the suction and discharge pressure analysis, compare that with the compressor current. So what we found out here in this situation was that the discharge pressure and the compressor current were both out of sync. And that was what was causing a huge amount of variance in the energy consumption in this building. And in this particular case, what we had to do was change the sensors and actually change this out of sync situation to actually drive the energy efficiency with the algorithms. So just very quickly to just capture what the 3 takeaways from this project was. One, we were able to get energy savings just by dynamically changing the set points for these buildings or these factories based on the weather conditions and environmental conditions and predicting what it needs to be. 2, about 7% by dynamically varying the variable frequency drive set points. And 3, close to about 10% by just changing the chiller sequencing and the chill water valve modulation to drive these savings. And as a result of that, just this limited period of time, we were able to get 9% energy efficiencies using these algorithms going forward. I just want to go on to 2 more points before I turn it back over to you, Giri, is that what we are seeing, not only is it about energy efficiency, but sustainability now in this COVID world is taking a much wider definition than just the narrow focus of energy efficiency. One of the things that people want to do is drive sustainability using computer vision models. And I'll just quickly share with you what we've been doing the last 20 weeks. One of the critical things we've been doing is, and what customers have been asking is that if you are able to do all this efficiency for us, how do we ensure that our workers, that is that 330-300 rule, how do we keep $300 investment safe? And therefore, what we've done is being able to train our computer vision models to detect when social distancing breaches happen. And we are connecting hundreds of cameras all over the world. And we've been able to do that sitting at home, connecting these cameras to be able to predict all these social distancing breaches and send out alerts. So what we do is connect any camera, no new CapEx, no investment required. Any camera or any thermal camera, we connect it to the edge box. That's where the brains are, which analyzes all this feed. And we send out an alert to the AI application that's given to the health officer, the safety officer, where he's able to detect why the breaches are happening, where the hotspots are being created to keep everybody safe. So we're able to use these technologies not only to detect people, but also to detect cars coming in and go out. So we can read number plates to check turnaround times. How do we reduce fuel? How do we how do we improve sustainability by improving turnaround times of trucks coming in and trucks going out? So you can see this live feed from one of the largest cement factories, where you can see people in green wearing helmets and safety jackets. In a few seconds from now, the camera will turn to the other side, and you'll see people in white without helmets and safety jackets. That immediately sends out an alert to the safety officer, the health officer, so that action can be taken where people are not wearing PPE and safety jackets. So that's how we are driving, safety from a manufacturing perspective and industrial perspective. This is one of the largest auto component companies in our country, where because of the lockdown, you're not seeing too many people. But this was taken from a camera that's about 7-8 years old at a height of about 30 meters. And why it's really difficult. What is you can more to the safety officer or the health officer that the social distancing has been breached. This is one of the largest steel factories where they want to do mass detection. So you can see out here people walking in with 50,000 people. So what you're able to see is people wearing the mask when they walk in, but they take off the mask when they go into the factory. So now rather than have that security guard stand out there, you don't need all those people because these cameras can now detect when people are not wearing the mask. But the use cases of driving sustainability and efficiency using computer vision models in the last 20 weeks has changed dramatically, whether it's from a quality perspective, defect perspective, safety perspective, security perspective. You don't need all these security guards staring at 60 TV screens anymore. You need one security guard because now the computer vision models are able to detect what normally 20 security guards would do. So therefore, it's driving huge amounts of efficiency in sustainability, resources, fuel, safety, etc. So much so that now what we can do in a lot of large manufacturing companies where safety is a big concern, especially oil and gas and chemicals, where they actually have a lot of DG sets, transformers, or electrical gases, etc. What the computer vision model does is the ability to actually detect when people are walking on that road. The computer vision model detects a safe zone. So it's the notional black box. So when people walk in, immediately it sends out an alert that someone's entered the safe zone in order to drive safety and sustainability in a manufacturing process as well. So the last point I just want to share with you is around tracking inventory management from a sustainability perspective. So what we've been able to do, like I said, use that little tag to track inventory and drive workforce productivity in this post-COVID world. So what we do is put that little tag, as you can see, that little black dot or an ID card, so that everybody, when they wear these ID cards and these little tags, or if you have larger IoT devices for forklift or an AGV, you're able to track real-time live where people are, where asset managed machines are. And therefore, you digitize your whole production floor, get all the data out through that locator, through the edge and the cloud. And what you're able to do is actually create an application that looks like this, where you convert your factory into a three-dimensional image. You're able to track where 50,000 people are here and now. So you can track where they are. So what you're really driving is sustainability from a productivity perspective to see, are people in the factory floor? Are they on the paint shop? Are they where they are? Then drive KPIs on the right side to drive productivity from sustainability perspective. So therefore, we do all this from our control center in Bangalore, where we actually get all this data. We actually therefore drive from our control center to drive whether it's energy efficiency, predictive maintenance in these large chillers or HVACs or boilers, in compressors. So from the control center, we're able to send out these alerts to drive efficiencies. So let me just end there by just stating 5 key takeaways for you before I log off. The first one is, I think as a result of COVID, there is a huge drive in driving what I call the healthy buildings or sustainable buildings or factories. 2, I think our ability to connect all parameters beyond just energy is going to be the key going forward. It's about water, waste, DG sets, transformers, because every element in that whole process is what will drive energy efficiency and sustainability going forward. So all of us need to think more macro, take a wider view in driving all these efficiencies. The only way we're going to do it to drive financial metrics and operational metrics is to actually drive it using AI and IoT. But let's think 2 steps ahead. Once we have all this data, I think 6 months, a year from now, we should be able to drive CapEx savings in the way we design buildings going forward, because you may not need that backup chiller or 2 backup chillers or the backup DG set, because if we are able to predict over the previous 10 years, see the cyclical nature of energy consumptions over patterns, connect that with the occupancy detectors, you need all these various parameters. The 5th one is sustainability. I think we really can drive sustainability in a very, very big way. And lastly, I really believe that technology is only one element of it. At the end of it, it's all about doing a more practical approach from people, process, to take a more practical approach in driving all this. So with that, hopefully I've given you a feel of what it's going to be like going forward in really driving efficiencies going forward. So with that, Kiran, let me turn it back to you and Giri.
Thank you. Thank you, Mr. Chopra, for an excellent address. I was noting down a lot of points in terms of summarizing your talk, but I think your last slide summarized it so well that I I don't have anything more to add than the summary slide that you mentioned, Mr. Chopra. I'll directly jump into the questions. There have been a lot of questions from the participants, a lot of interest that is generated on this subject. So in the interest of time, I'll directly start with the questions, Mr. Chopra, if that is okay with you.
Sure, please, over to
Yeah.
you, Kiran.
Sir, you mentioned about the different protocols which different manufacturers have been using, and there are a few questions revolving around that in terms of how do we demystify the language that is being used by different manufacturers? How can we talk about the protocol which is more kind of uniform across different manufacturers? Is there any work that is happening in terms of bringing a unified protocol, particularly with more and more industries looking at automation as their next big thing in terms of implementation? In fact, some of them have also written that the decision making and implementation is becoming so difficult because the language spoken by different manufacturers are so different. So, any thoughts on that, sir?
Yeah, Kiran, it's a good question. And having spent most of my life working for a large multinational, I've seen both sides of the equation, right? At the end of the day, creating that hard-coded protocol is the reason how you protect your own service model going forward, right? And that's where the manufacturer come from. And having, like I said, I've seen both sides of the equation. I can completely understand their perspective, and rightly so, Kiran, because these large corporations spend a large amounts of money in R&D over many, many years, and therefore they want to get some return on that huge R&D investment. But on the flip side, Kiran, what I just say is this. So the answer, Kiran, is there is no standardization. Now, there are discussions in the world. There's a thing called OSs that are talking about standardized protocols, but it's been in discussions for a long time. So I don't know, frankly, when it's going to come. But this is what I see, Kiran, that gives me a lot of hope. The pace at which technology is changing is going to change the way that I don't think that's going to last for too long, right? Because I keep telling all these large manufacturers at the end of the day, today you have open source platforms like what we're trying to do, but I don't care whose protocol is, we'll find a solution on how to make it communicate, right?
Okay.
So therefore, I think the speed at which technology is going to progress will overcome, number one. Number two, I also feel that a lot of the OEMs are now beginning to realize that that's not, I think the pace of technology is changing so fast, they might as well just get onto the same platform to make it that open platform. So I think, Kiran, that's where the world is going to go. I think the large corporations who make a lot of these IoT devices and sensors get it. And I think over time, it's automatically going to change.
Thank you, sir. There were 2 points that you mentioned in terms of capturing the benefits of automation at times can be difficult. And you also mentioned about taking it from a CapEx mode to an OpEx mode for implementation. Now, there are a few questions revolving around how do we capture all the tangible and intangible benefits which implementation of a good automation system can bring in. And second, are there any innovative models being looked at in terms of implementing rather than significantly high capital expenditure for industries today?
Yeah. Kiran, I think what excites me is the fact that what you're trying to say is exactly what we're trying to do is how do you disrupt the business model? How do you change the business model from going into a very CapEx heavy mode into an OpEx mode? But I think a couple of things give me hope. One is the fact that I think today in the world of IoT, already a lot of sensor prices have come down, number one. Number two is technology pace of network reliability is also improving a lot, whether it's 4G, private LTE networks. I think the network capabilities has improved. And I think with the upcoming 5G network, that will transform the way we do AI and IoT to drive productivity in this whole world of Industry 4.0. So I think that's a huge process that's happening already. The third thing I would say is that at the end of the day, I don't know everything, right? I know very little. I'll always know just a little fraction of what somebody who's made steel for 50 years on the factory floor, or somebody who's made cars for 40 years all their life. It's very difficult for us to get to know as much as what they would know. However, the success we've seen with large corporations is when our domain experts and our data scientists work collaboratively with the client itself. So for one of the biggest utilities in Europe, our team has had a weekly or a bi-weekly call for every week or every 2 weeks for the last 6 to 7 years. It is that level of collaboration. And the reason I say that, Kiran, is this: computers will tell you black or white, but there are also shades of gray. So sometimes the computer might say, shut down the turbine in 48 hours because we're seeing excessive vibration, or we are seeing temperature high in the gearbox going up, or we are seeing a valve pressure going up very, very high. But there is sometimes a human element that comes in, where the human element says, I've seen this problem before 10 years ago. This is what we did, so we can run the machine another 20, 48 hours before the shutdown, because it's peak season, high revenue generation. So let's shut it 48, let's run it 48 hours. So I just want to share that also with people, is the fact that there is an element of human science and art versus science as well that comes into this whole world of predictive intelligence.
Thank you. So there are two sets of questions on the preparedness of Indian industry towards adopting automation and a kind of a digital transformation. One set of questions are on what is your view on the preparedness of the industry today? Some industries are new into this. Some industries have had legacy automation systems, and I mean, automation has been in existence for some time, but not at the current pace at which it is in. So, how do you see the preparedness of the Indian industry today? That is one question, sir. The second set of question is how do you see the development of solutions coming from India? Do you see a lot of Indian technology suppliers? Do you see a lot of hardware and the software developers from India being available today, which can both make it more accessible as well as maybe at a much lower cost than what it would be if it had to be taken from maybe the Europe or the American market? So on both sides, how is the preparedness of the industry in adopting this? And secondly, how is the supply of both the hardware and the software from the Indian ecosystem to meet the demand?
Yeah, no, great question, Kiran. Thanks for that question. I think COVID has changed the world, right? Think about it, right? Over the last 20 years, right, manufacturing has shifted east: China, India, Indonesia. So a lot of heavy manufacturing has moved from the west to the east. And therefore, my perspective is that in the world of manufacturing, it's actually moved to our side of the world over the last 15, 20 years. And therefore, every large corporation has some manufacturing base in this part of the world. Now, therefore, I feel, therefore, we have an incredible opportunity to take the lead in this whole process of AI, IoT, Industry 4.0, number one. Number two, us in India, unfortunately or fortunately, over long periods of time, we've never had access to vast amounts of capital. And therefore, what we in India have been good at, being very good at frugal engineering or frugal manufacturing. How do you take very small amounts of capital and stretch it to a long, long way? Now, in this disruption of COVID, where supply chains around the world have been broken, the world is now looking less on a reliance on labor, but more on technology and productivity. Nobody's going to go out there right now and saying, let me go hire another thousands of people. Everybody's saying, how can I take what I have and get more juice out of it? The only way you can get some more juice, whether it's on the revenue side or on the cost reduction side, whether it is energy, efficiency, raw material, all the elements that go into manufacturing, is through digitization right now. So therefore, going back to your first two questions, Kiran, preparedness of India, I think the good news is I don't think anybody in the world, okay, the China is ahead because they've had the ability, the capital to invest very large sums of money. But my perspective is that in the world of manufacturing, I think we have an incredible opportunity to actually not only catch up, but leapfrog parts of the world in this whole game of productivity in AI and IoT, for all those five reasons that I mentioned to you earlier. Because I tell people, the game is not somebody sitting in California. It's not even me sitting in Delhi. It could be a small guy sitting in Kanpur or Nagpur that has access to the same technology that you and me have sitting in our offices where we are. And that's what gives me a lot of hope for our country, that we have that ability to catch up with everybody else. And two is, do we have the ability in India, the solutions, the technology? Absolutely. Because it comes back to that fifth point I mentioned to you earlier on, it's human capital. I don't think any country has that level of expertise in software, technology, understanding as we do. It's us for us to lose, Kiran. I really believe that we in India have this opportunity to disrupt the world in manufacturing using AI and IoT going forward. Kiran, you're on mute, Kiran. I can't hear you.
Sorry. The next question was in terms of the role of the government in accelerating the adoption of automation and a kind of a digital transformation in the country. One, do you think they should be playing a role or playing an accelerating role? And if so, what should be the role? Second, the government of India has also launched the Samarth Udyog towards Industry 4.0 program. Do you see that doing good, or what more do you think at a policy level we should be looking at in terms of this transformation to happen very quickly, sir?
Yeah, Kiran, I really do believe the government can play a very, very critical and pivotal role. And we need them more than any other time in our lives, especially given in a post-COVID world where it's disrupted the whole world. First of all, let me just say that I must say I'm really impressed with what the government has done to date in the world of AI for themselves. In terms of the way they're thinking about it, they're driving it in terms of establishing that for their own systems and processes, in digitizing different departments, etc. So I must say hats off to the government. But where I think the government can really help us in industry is on a couple of areas. One is if we can get more investment in AI, in core AI, that would be fantastic, right? Number one. Number two, skill building. We need not hundreds, not thousands, but tens of thousands of data scientists, IoT experts to make this a mass scale revolution. And therefore, if we can get government support to make that training happen at that scale, that's the other area that I think we could go a long, long way. Three, make access to R&D more easier. Now, maybe the government may not be able to help, but I think what I see in the United States, the collaboration between industry and universities and educational R&D, educational institutes doing R&D is significantly higher than what I see in India. And therefore, how do we bring educational institutes and industry together to drive this? I think those are three areas, Kiran, that I think the government can really take the lead in providing help and guidance from a policy framework to really make us the leaders in driving efficiencies. Because like I go back to my first point, the world is broken. Manufacturing supply chains are broken. This is our chance to catch up with the rest of the world and attract all the investment to make India a manufacturing hub. And not only because of capital, not only because of labor, but because of our expertise to provide technology solutions to leapfrog and catch up with everybody else in the world in terms of quality and manufacturing costs going forward.
Thank you. Sir, you mentioned about the involvement of educational institutions, and there is one interesting question around that, which talks about how do you find the quality of professionals who are coming into this space today? Is the educational curriculum today abreast with what the industry's requirements are? And if the gap is too high, is there anything that the industry is doing about it in terms of bridging that gap?
Kiran, if I want to be really frank, I'll tell you what my big problem is, right? When we interview people, right, literally, we might interview about 30 people or 40 people to get one. That's the challenge, right? Because the problem is while there are lots of good engineers, lots of good data scientists, but to find that one data scientist or that one developer or that one IoT expert that has the experience and the ability to make transformation happen is very difficult. That's the problem we have in our country, is that the base is very wide, but the number of specialists that we can get to drive that change is not that many. And that's our challenge. And I think, Kiran, to some extent, one, we need to raise that base by education. But two, I think all of us in industry need to come together to really create an accelerated approach to really create that world of expertise that we actually need going forward.
Thank you, sir. I know we are just at 5 p.m. right now. Our scheduled time is up, but there are just two interesting questions. I'll take it up, sir, to take your views on it before I hand it over for you to your last words for closing the session. One question is on how is the startup ecosystem around this space in the country, and are you actively working with the startups in encouraging them in kind of providing your insights so that they could accelerate and deliver better? That is the first question. And the second question, which I'll mention it so we could take this up as well together. The second question is on how do you see the relevance of automation coming in and transforming the small and medium enterprises, sir? While a large number of examples that you've provided was for large industries, the cement, the steel, the automobile. But what is the role for automation in the small and medium enterprises who are facing variety of challenges in today's situation? How could this really help them solve some of their very key issues? So first question is on startups, second is on small and medium enterprises, sir.
Yeah, no, thanks, Karen. Again, good questions. Uh, on the startups one, absolutely. Very keen to engage with startups because I tell everybody no one company has the answers to all the solutions that exist, whether it's steel, chemicals, auto, energy, utilities. So the question is, how do we create that ecosystem to do it? The challenge I have, Kiran, is how do we reach out to that system? Now, there are a lot of startups, no doubt, but I find the majority of startups are focusing on the B2C space, whether it is in the delivery space, whether it is in terms of the payment fintech space. There's a lot of work happening on CRM, ERP, but I just don't see, as far as I know, and maybe I just don't know enough, that many folks who are focused on the B2B space. Now, the B2B space, Kiran, is very difficult. I'll explain to you why. Lead cycles are long, right? It's not one consumer who's buying, a SaaS $10 product, right? Or a 100 rupee tool. It's a much more complex sales cycle. One, two. You need domain knowledge. Nobody's going to let you into a steel factory if you don't know the basics of steel making or auto making or energy or turbines, right? Nobody's going to let you touch a $3 million turbine if you don't know enough about it, right? Three, you have a lot of decision makers: CEO, CFO, factory manager, plant manager, worker, engineer, R&D. So unless all these 10, 15 people have buy-in, it's not going to move forward. And therefore, this B2B space it's very, very difficult. It's a huge barrier. It's a huge barrier to entry. And that's why the urgent appeal that if industry, CII, us, all of us can work together, right, to really make this happen, that's what it needs. It's not me trying to do it myself. We need all of us to come together for the three reasons I just mentioned. That's different in the industrial world than trying to make a small little startup, trying to make a product for a consumer app or for something, because you need deep process control, process systems, quality, manufacturing. How do you drive it from it? It's not about putting one sensor. It's about how do you understand the whole manufacturing process when you make a car? How do you actually reduce the wastage? How do you know? So it's a much more evolved process to do these solutions. In terms of MSME, Kiran, that's my dream, right? The dream is not only to provide it for the big guys, because the big guys will figure it out eventually. They have the resources, the power, the might to go do it. The question is, how do you bring it down to that cost level where we can provide these solutions? And that's what I'm trying to do, is to be able to provide an affordable, call it an IoT in a box solution or an AI in a box solution. How do we create a small package solution for MSMEs? Now, the challenge, Kiran, is scale. Because the problem is the time and effort it takes to train an algorithm, to train one model is so long, right? We are trying to shrink that cycle. So the question that I have is, can I take an algorithm that we've created to do predictive maintenance in a wind turbine and apply it for the textile industry? Can we apply the predictive maintenance as algorithm for auto industry? So that's what we're trying to do to make it more affordable and viable for the MSME sector. So I think that's another thing for all of us at CI and us to also think about, is how do we find a simple way, Kiran, to take these solutions to MSMEs to really drive a difference? I have lots of ideas on how we can do it, but I think we need both of us to think about how do we come together to make a difference in our country.
Thanks a lot, sir. We are well past the time that we had taken from you for today. We thoroughly enjoyed your lecture and the interaction that followed it. You answered all the questions that were raised on the platform. Thank you very much. Thanks for your time. Thanks for your address. And I'll now leave it to you, sir, for just a minute or two to just close the discussions with your summary on what next, and we could close the discussion, sir.
No, thanks a lot, Kiran. Thanks so much, Giri, for inviting me. First of all, really appreciate it. If we can have a small little impact in making a difference in our country, that's what gets me excited. And I just want to say that I really do believe that we have the power to dream and think and really disrupt the way manufacturing was done, how energy efficiency was done, sustainability was done. Now going forward, we've done all the old, in the past, we've done a lot of the other ways, traditional ways. But I think now going forward, we have a very, very easy, strong opportunity to really, beat the world and provide these solutions at a large scale across India. So with that, thanks a lot, Kiran, and thank you so much, Giri, for giving me this opportunity.
Thank you, sir. Thank you.
Thank you very much.
Thank you. Thanks a lot, sir. Thank you.
Thank you. Bye.